Hey everyone, welcome back to the third session of Unreal Behavior Trees. So this time we're going to get a little more fancy with our behavior trees. You know, as a brief recap, we've got this guy running to that spot and doing nothing, which is super exciting. Let's make this more exciting. Now what I want him to do is I want him to basically follow me, at least on some level. So that's going to require some kind of basic interaction with the player in terms of running and catching me. And it's going to require us to I want us to be able to make some decisions, because I only want him to follow me if he's within a certain distance. So that's the next step. And so lets us talk about a bunch of different things. The first thing it lets us talk about, and I'll go back to these diagrams here, is how do we make decisions? We have tasks and we have these composite nodes. And I kind of hinted that we need to do if statements of some kind, right? We need to make decisions called branching and that kind of stuff. There are two major things that we haven't talked about yet. And so the first one I'm going to introduce today, which is called decorators. So, and I'll represent them with a diamond. So a decorator in Unreal is a decision. Now, you know, I've said in a couple places I'm going to do kind of like the programmer's aside. So, you know, for just a minute, and for those who are interested, I'm going to go over here and I'm going to light the programmer lamp. So in the real world, and those of you who have studied like object-oriented programming, you know that there is this thing called a decorator, where I basically have this class, you know, which sort of contains this other class, you know, which can contain this sort of other class. And so conceptually you get this thing here that wraps it, this thing here that wraps it, and so on. This is a decorator design pattern. And if you're curious, you can Google decorator design pattern, and you should find all sorts of information about what a decorator pattern actually is. And you can see all this stuff. And so if you know what a decorator pattern is, for some people it might sort of throw you for a loop that, I guess no pun intended, that Unreal uses the term decorator to mean condition. And I think at its simplest, that's the way to think about it. It's a condition. The reason why they call it a decorator is because if you dig into the actual Unreal 4 code, it is literally implemented as a decorator. It is only, it's just a decorator object. I'm going to call it decorator because that's what Unreal calls it. You can think about it as conditional. That's all it is. It is a conditional. So you can think about it as basically wrapping the node. So here, I'll draw another one over here. The way that I'll probably tend to draw this when I have to draw these is I'll do something like this. Like, here, let's just do this. And then maybe this has a conditional. And I'll do something like that. And then like that. Seems reasonable. And then what is this conditional? You know, maybe player is near or something, right? That's kind of what that's kind of what I'm going for here. So that's the idea. That's what a decorator is. It's just a conditional. So how do you make one? And what does it do under the covers? Under the covers, all it really does is run some blueprint code or C++ code if that's what you want to do. It just runs a blueprint function that you write that returns a Boolean yes or no. Did this succeed? If this fails, I'll tell you what, let's do this. Let's say that we have this guy where we're going to move to the player or whatever. But let's say that we want to have this conditional. I'll just do it like that. And it's the same thing, like, is the player near? Or something like this, right? We don't even want to bother with this. So what's going to happen is if the player is not near, this will just fail, right? This will just die, and then this whole thing will fail. It won't even try and run any of this stuff because it's a sequence, so it's going to fail immediately. Similarly to here, you know, if there's a conditional here, what it's going to do, like let's say this is a conditional, what it'll do is if this fails, it's not even going to bother, right? It's not even going to try and run this. This conditional failed. It'll then try and run this and so on. You know, we'll see what happens. It's just a way to bail out of something without having to like directly fail it. Now, can you write a task and just have the task fail if the if you don't want it to go? Like, can you just execute the task and have a bunch of tests in the beginning? Yes, you can. Should you do that? No. And there's a couple of reasons why. One, I'm pretty sure they optimize decorators in a way, and there's certain things that you need decorators for, and I'll show you, probably not today, but later on, I'll show you some of the, you know, advanced stuff you can do that require decorators. So any conditionals that gate access to a node really should be a decorator. The second thing, and this gets also very important, is that decorators can be self-documenting. What are the conditions for being able to enter this node? They're right there. I don't have to dig into the node itself to figure out what those conditions are. The more important of those is the features that you get with decorators of being able to like interrupt action. So it's really being able to do interrupting things, which you can do with decorators. What I want to do is I want to have this guy come up, and if he's going to test where the player is. So, you know, if I'm going to do it kind of flowchart style. If player is close. So if the player is close, then we're going to run a little sequence. That sequence is going to be go to player. And then we're going to wait. Waiting is fun. Otherwise, so if let's say this fails for any reason, what else can we do? We could wait. That seems boring. But what I want to do is let's go to our position. In fact, we're going to do the same thing. We're going to do a sequence. And we're going to say go to that position that we had before. Otherwise, and then after that, sorry, because it's a sequence, we're going to wait. Basically what we're doing now, except that we have this other thing where we can follow the player. That's it. That's all we're going to do. Let's just, if I hit, I'm hitting Alt click, by the way, it just disconnects these nodes. So I'll just move these guys over here. We'll use them later. So sequence, let's look at what we have. We need to have this decorator. Decorators always wrap nodes. So what do I mean by that? Well, let's look at this sequence. Wait, this is a sequence. So we want a selector. So I'm going to pull this down. I'm going to say selector, right? I'm going to drop this over here, and I'm going to say sequence. So we don't drop a decorator. Like, I can't just drag this and say, you know, decorator. What I can do is I can right-click on this node, and I can say add decorator, and I have a whole bunch of cool stuff I can do. The most common one is is that location. That's pretty common. Check gameplay tags on actor. Oh, Blackboard. It's at the very top. This is probably the most common. It basically checks to see, hey, is this thing set? So we'll make good use of that. What we want is this particular thing close to us? Well, I don't really see anything here. So what we're going to do is we're going to write our own. And this is going to be the first time we've done this. So let's go to... no, I can't do any of that. So I think I just have to do blueprint class. And then you want to inherit from... And then there's a bunch, right? So I can just go decorator. Here we go. You want BT decorator blueprint base. And we're going to call it... is... I'm going to say player... Yeah, I'm gonna say is actor close. That's what I'm gonna call it. And so all I did was double click on it, and there's a bunch of stuff. Here's how these work, and you just sort of have to know this. go to functions, because there's nothing here in the event graph, notice. Go to functions, 12 are overridable. Click override, and these are the functions you can override. There's a bunch of stuff here. Specifically, you want this perform condition. Notice that half of these, like they're duplicated, but some say AI and some don't. So you perform condition check and perform condition check AI. You want the AI one. The difference is the non-AI ones are sort of an older interface, and they don't have like the controlled pawn, for instance. So all I did was I'm overriding that function. Perform condition check AI. That's it. This gives you these two things. It gives you the owner controller, and it gives you the controlled pawn. Those are the two things that you have. In addition, you have a return value here. If this returns true, the condition succeeds. If it returns false, the condition fails, right? Simple. So I'm going to disconnect these because I need to do stuff. So I said, is actor close? So I could go in here and I could like, you know, let's do this simple one first, and I'll show you how to make it better. What I'm going to do is I'm going to say get, you know, this is the classic, like get all actors of class. Get all actors of class. And so, you know, we're going to get the player, which is the only third-person character in the game. So here's our thing. Here's all of our actors. Get. And then in here, I can basically say distance. Probably the easiest thing to do is to do controlled pawn, get distance 2, and I'll just pull him over here, pull him down here. So now we have a distance, and then here, you know, we can create, you can do whatever you want in terms of tuning, by the way. So let's actually create a little variable here, and this variable is going to say, you know, close distance or something like that. Let's set a few things here. So we're going to set this to a float. Call it close distance. I always write a tooltip for these. So like the distance that is considered close, right? What does close mean? We're defining that. And let's compile this guy. And let's make this guy public as well, so that we can tune it. I don't know, what's a good distance? 10? A little bit further than before? That seems right. This is just a default. So now what we're going to do is we're going to do a little branch. So we're going to say if, and we're going to go here, and we're going to say if this is less than or equal to our close distance, then this condition is true. And in fact, I don't even need this condition because I can just return this as a Boolean. Okay, I'm going to zoom this out a little bit. So what this is going to do is this is going to say, get all the actors, right? We're going to grab the first one. This is a hack. I'm going to label it as this. We're not actually going to do this. I'm just doing this for simplicity. I'm going to say hack. Because I'll show you the more correct way of doing this. Then we're going to basically grab this distance. And let's see if I can clean this up a little. That feels better. We're going to check the distance. If our distance is less than or equal to the close distance, we have succeeded. That's what close means. That's it. That's our decorator. So let's close this. Now if I right click on this sequence, I can go to add decorator, and is actor close? There's my thing. It has the tuning value. I can change this to whatever I want. So it's pretty sweet. I can also name it. And here's the thing. This will be true and run this sequence if we're close. This isn't exactly what we want. We actually want the opposite of this. We want if the actor is not close. So, you know, I could have gone back here. I can double click on this. I could have gone back here and I could have said, you know, I could have inverted this. But when you're writing nodes, you want to make them, you don't want to do negatives or double negatives like that. You don't want to say is not not actor close type thing. And Unreal gives you this condition, inverse condition. If I click this, this thing basically has a not around it. So now I'm saying if the actor is not close. And then also a good practice is rename your nodes. Is not close. Right? Now, anyone looking at this script, anyone looking at this tree, this is super obvious. Is not close. That's it. You know, do I want to see the property details? Yes or no? You know, there's little things here. Okay, that's it. It's going to check this before it even bothers with this sequence. That's the magic of this. So let's do this. I want to move to, here we go, move to, I want to move to the player. That's correct. And that's it. Oh no, I want to do the wait. So let's do wait. Wait for some amount of time. I'm going to actually wait, 5 seconds is fine. So if I go back to our list here, that's this section. Now, otherwise, I want to go to the position and wait there. So if this fails, we want this guy to come out to another sequence. So let's pull these guys over here. And then this sequence is going to be move to. We don't want him to move to the player, right? We want him to move to the target position. So we'll just tweak that. And then we're also going to wait. And we'll do the same thing. We'll have him sulk for 5. By the way, it's not going to be exactly 5 seconds, or it doesn't have to be. So wait time, there's a random deviation I can choose if I want to. Right now it's 0, so it'll be exactly 5 seconds. But I can, if I change this, for example, to 1, it would be a random number from 4 to 6 seconds. So you can do some cool stuff like that. Okay, that's it. So this is our simple behavior tree. Will this work? No. The reason why it won't work is because player is null. In fact, if I run this right now, it's going to, so it tries to go and then fails. So what's happening, and we can pause and step back. What happened is notice these red arrows, move to failed. I guess I don't need these guys. Move to failed because we don't know the players. We've never set this variable of player. That's why move to failed. And I kind of wanted to show you this so you could see the failure case. And of course, we know what happens if a sequence has one failure, it's not going to bother with the wait. It's going to fail out and try and do this thing. So what we're going to have to do is we're going to have to initialize the player. And we do that in the same way that we did that here. Again, this is going to be kind of a hack, and probably next video we're going to remove these hacks. But I'm basically going to do the same thing, right? Get all actors. Sometimes I feel like I know that my design has failed if I ever call get all actors of class. Somehow my design has broken down. But this is just a hack, so this is fine for now. Let's see, we'll do a get, so we'll get this guy, and again, we're just getting the first one. This is all terrible practice, but again, I'm just trying to simplify the hell out of this. Blackboard, so we'll grab the blackboard so that we can do set value as object. And notice that set value as object, the target is not ourself, the target is always the blackboard. It's the same thing here. So that's one kind of gotcha there, is that most of the time you can use this sort of target. Okay, you come from here. Let's move all this stuff. I know this is kind of temporary stuff, but this is going to bother me. So we'll drag all this stuff over here. And, Blueprint will get super messy if you let it. So it's best not to let it. So here we want to, do the same thing. We promote this to a variable, target, or I'm going to say player key. And I think you guys get this for this part. So probably in the future, I will cut out creating all these stupid keys. By the end of this, we're going to have probably a dozen keys. Okay. And this is going to be player. Again, this has to match what is our blackboard. So in our case, blackboard is this player variable, so it has to match exactly. So we've done that. So now we've initialized this guy. And again, whenever you do this kind of stuff, you know, you can do these hacks. At the very least, call it out. And we're going to delete all this stuff. In fact, yeah, we'll do that. That's fine. That's it. This will, this is also not going to work exactly right, but this is going to be much closer. What I expect now is he's not close to me, so I expect him to charge me. Here he comes. So he's here, and if I run away, he's not going to do anything for a minute because he's idling. You know, that 5 seconds has to go by, and then he's going to come after me again. So, one question, if we stood here for a while, like if we stood here for more than 5 seconds, he's not going back. And so there's a bug there, right? He's not going back to where he needs to go. So, you know, if we... Here, I'll stop it so we don't see the debug stuff. If I go back here, you know, we expect him to get close. And once he's close, he'll wait, because this will have succeeded. And then he should be close, so is not close should fail, and he should come down here and move to target position. But he's not doing that at all. So what's going on? If I pull this over, I'm going to do what I did last time, right? I'm just going to start this in this tiny little window. And we're going to watch this part of it and see, you know, I have to zoom this out a little bit, but we can kind of see what he's doing. So he keeps moving to and waiting, moving to and waiting, moving to and waiting. So what's going on? You know, move to is clearly kind of succeeding. And in fact, if we pause this, we can see that move to has succeeded. And if I just keep backing up, like wait succeeded up here. So we reran move to. So in other words, what's happening is not close keeps succeeding. It still thinks I'm not close enough. My distance of 10 seems like it's not quite right. So now what? Well, if you've done any debugging in Blueprint, this should be pretty straightforward. But if not, let's do that. All I did was double click on is not close. It doesn't pick up on what actor I care about, so we have to use this little drop down, and we use this guy. And so, yeah, this is right. So now what I want to do is I'm just gonna resume this, and we're gonna watch this go. So eventually this will pulse. There we go. So yeah, I mean it's just running. If I go here and I right click, there's an add breakpoint. And what this is going to do is now, once this node gets hit, it's going to stop everything, which is really cool. Because now I can hover over things. And I can be like, what's going on? Like, what actor did I get? And if I hover over this, there he is. That's the actor I got, specifically. What we really care about is this should be failing, right? So close distance is, come on, is 10. Distance is, ooh, 76.9. So he's kind of far. He's actually kind of really far. And so that's just a bug. Our number is just wrong. So I wanted to kind of demonstrate this a little bit so you can just sort of see, oh, this is a simple debug of like, how do we see what these values are? And then of course I can go here and I can say remove breakpoint and I can hit resume and he's going to keep doing his thing. So let's fix this. This should be a really simple fix. There's a couple ways to fix it. I could just go here into the behavior tree and just set this value to 10. But now we know 10 is probably a totally unreasonable value. So what I'm actually going to do is I'm going to go in here and change the default to 100. That seems much more reasonable. So now the behavior that we want is probably, behavior that I expect I should say, is probably what we're going to get. Oops, not you. So let's give it a shot. Play. Here he comes. He's here. Oh, notice what happened. Hold on. I'm going to watch him go. Off he goes. He went to his place. Okay, stop. I want to show you something. And let's see if I can get it to do it again. Watch is not close. Watch it. Okay, here it comes. Now watch it. See if it does it again. It should. There it is. Pause. Oh, went away. I'm going to have to go backwards. Step back. There we go. Notice how it's flashing and turning red, and there was a little red vertical bar. So this says the sequence, like nothing in here failed. It failed because of this. And that's super important. It's kind of obvious in our case, but many behavior trees, you might have a sequence that has 4, 5, 6 7, 10, 20 decorators on it. Which one failed? There you go. You can see it again. It failed. And this is what we want. This is the behavior that we were looking for. He comes over to me, says hi. Hey, buddy. And then he leaves. He goes to his little corner. That's the behavior that we wanted. So that's how you can use decorators. And notice he's just going to trounce on up here. So anyway, that's what we got. That, I think, will probably do it for this video. Next video, I'm going to show you yet another node in Unreal called Services. That'll be fun. So that's it. I hope that you enjoyed this. Let me know if there's anything, you know, that could be different or that could be better, any of that kind of stuff. And if not, then I'll see you next time. Talk to you later.